Good morning. So first, I'll take your attendance. So please look in the chat window and fill this form. Okay. And some of you are yet to complete yesterday's Friday's program. I don't know why you have not done that. So just give me a moment. Yeah, I hope everyone is filling it. Okay. Yeah, so till now we were seeing forces, concurrent forces, and the resultant different methods. Okay, so now again we will continue with this. So today I want you to get introduced to a topic called equilibrium. Equilibrium. Okay, so what is equilibrium? Equilibrium means so basically when all the forces are acting on a point, all the forces acting on a point or concurrent forces acting on a body, results to have a zero force. Okay, എല്ലാ ഫോഴ്സിന്റെ റിസൾട്ടന്റ് സീറോ ആണെങ്കിൽ we'll say that body is in equilibrium. Other we will see how it can be done. Okay, so for example, so let's say we have a system of forces. This is a body, some bodies here. Okay, so this body has been acted upon by two forces, 10 kilonewton magnitude, but two forces acting on this body. Okay, so it can be any direction. So let's say നമുക്ക് ഇവിടെ ഒരു കല്ല് കിട്ടിയിട്ടുണ്ട്. Okay, so കല്ല് നിങ്ങൾ ഒരു കയറ് കിട്ടി കല്ലിലോട്ട്, then you're pulling it. Okay, so this is the force. So basically the force sort of missing under that. I will tell you what it is. But then one force is acting like this and one force is acting like this. Okay, these are external forces. These are two forces. I will assume it. So it is some condition like this. You don't know how to draw this. I'm just telling you. Okay. Right. So now, how do you find the resultant of these two forces? So can you quickly find and tell me what is the resultant of these forces? Because there are many ways of finding the resultant. So I told you the best way is, x-axis, that is the resultant components. X component of resultant and y component of resultant. Okay, this is how do you find it? So this is 45 degree and this is 45 degree. Okay, so when you have images, it is always easier to find the resultant and all. A problem you have to try and make images like this. Okay, so further we will know that this kind of images is what is known as free body diagrams. It is not a completely free body diagram. Free body diagram I will tell you, but the idea is this kind of images is very important. Okay, so this is 45 degree, this is 45 degree, this is 10, this is 10. Okay, so you tell me what is the x component, what is the x component, and what is the y component of the resultant. So if you have calculated yeah,
x component is 0, sir.
X component is 0. Who is that? Aravind. Okay, let's see. Aravind is telling me x component is 0. So let's see, one option is 0. And y component?
Yeah. 14.14.
14.14. So if there is any other answers you can tell, where are you answer? You answer for yeah. Bibin Jacob undo.
Yes, sir.
Bibin Jacob answer kidiyo. Cheyu. So let's say first component x component. First we have to find x component. X component of x component what you have to do is you have to find x component of this force and you have to find x component of this force. Okay, so I will directly write. So first force into x component or either. So if I complete a triangle like this is the x component. So this value is 10 cos 10 cos 45, and this value, this is y component. Okay, we are talking about x component. Then I'll complete this triangle also. So this is my x component. So that is 10 cos 45. Only thing is, this negative direction, the positive direction. That you have to see. But this magnitude is what we need. So this is equal to. So this will come up with a negative sign, right? Because it is the negative axis. Okay. So 10 cos 45, 10 cos 45. What do you get? 10 cos 45 minus 10 cos 45 to 0. So this what is that is correct. Okay. So E direction it is 0. Now what is y? What about y component? Y component this is the y component. Y component of this force is 10 sin 45. 10 sin 45. Okay, so now this is in positive direction, this is also in positive direction. So we have to add. So this gives me 10 sin 45 plus 10 sin 45. This is equal to 20 sin 45. 27, 45, 14.14 ആണോ?
Based upon this particular hydration, we can modify.
Yes, sir.
Yes, 10 root 14.14 kilonewton. Okay. Okay, right. So this one observation you have to make is the object on the okay. Object on the what we are seeing is the resultant in the x component 0 in y component 10.14. I'll just make a copy of this. Okay, so page into our copy. So let's see. Okay, so now we can check with the in the area. Okay, we can use our graphical method also. Okay, so graphical method and the there are many methods. What I'll do, I'll take this and put in the tip here. Okay. This force also I'll take. Right. So this is my result. Maybe I'll use thicker line. This is my result. Okay, so you can resultant, you can see resultant there is only in y direction, x direction is getting cancelled. X component is this is cancelling each other, and if you see the resultant doesn't have any x component, resultant only have y component, and this magnitude is equal to e length this is equal to sorry this is equal to 14.14. Right. So we can see there in our system. When I took this and keep it in the triangle, that is polygon. Force so what has happened is this force is only in this direction. Okay, so this body is said to be in equilibrium in x direction. So this is said to be in equilibrium next direction. Then the resultant doesn't have any x component. Okay, this body will move only in y direction. X direction it is in equilibrium. Equilibrium moving. Okay, but y direction it will move because the forces are like that. Okay, so this is what is about equilibrium. So one body complete equilibrium. It should not have any x component and it should not have any y component. Okay. Now the same question. Let me make another copy now. So let's say so I told you this system can be idealized or a block is there. Let's say there's a block. Okay, this block is being hanged by 2 threads. Okay, so let's say there is a small pulley here. So some forces acting. Right? The forces. So the force is acting as 10 kN. Force is acting at 10 kN. So this angle is 45 degree. This angle is 45 degree. Okay. This weight block. This is correct. This is correct because there is no other forces. Okay. Now, if there is another force, let's say the weight of the block. Weight is always acting on W. And let's say the weight of my force is 14.14. Okay. My system is not complete. Okay. Weight this is okay. Okay. This body point that assume idealization. This body has been assumed to be a point, and these forces are concurrent. All the forces are passing through this point. Okay. So this is also concurrent forces assume no problem. Very good. Block under. Value block under. This may not be concurrent. The point act. But this is a very small block, so we can assume that all the forces are acting through one point, right? Okay, so idealization, concurrency. Idealization, this has been idealized to a point. Concurrency means all the forces are passing through this one. Okay, but this system is not complete now. I have to add my the last force, so that is the weight. The magnitude of this is 14.14. 14.14. Okay, now we have a new system of forces. So I can drop this off. Okay, so now what you have to do is you have to find the resultant of this. You have a new problem. Okay, so one force is this, the second force is this, and third force is this. So what is the x direction resultant and what is the y direction resultant? Work out here. This is the first force, this is the second force, this is the third force. Okay, this is 10 kN, this is 10 kN, this is 14.14 kN, and this is 45 degree, and this is 45 degree. Right? How do you, what is the result? Resultant x component and the y component. So just try this out and tell me what is the answer. Abhishek Vinod.
Present.
Abhishek Vinod. Say that.
Result in the 0.
Abhishek Vinod, Manata Friday, this is Chedilla.
Illa.
Paranoia.
Sir, in the chair.
Okay. Resultant 0 on the Abhishek Vinod.
Analytical method.
Analytical method.
Originally, then the
Originally, this is
0 ആയിരുന്നില്ലേ?
0. എനിക്ക് മനസ്സിലായില്ല, ഒന്നുകൂടെ പറയാമോ? അത് ചോദ്യം എനിക്ക് മനസ്സിലായില്ല.
അല്ല, അനലിറ്റിക്കൽ മെത്തേഡിൽ ഓരോന്നിന്റെയും എഡ്ജിൽ വെക്കുകയാണെങ്കിൽ തിരിച്ച് 0 തന്നെ വരില്ലേ എന്ന്.
അത് അനലിറ്റിക്കൽ മെത്തേഡ് അല്ല, അത് ഗ്രാഫിക്കൽ മെത്തേഡ്. Okay, fine. Right. Okay. So you can do that, or you can find the x component. Okay, you can calculate here. The x components I have written. This x component. So my x component, resultant x component is basically minus 10 cos 45 plus 10 cos 45 equal to 0. Okay, x component. Now y component is not. So this is for resultant. Resultant of y component. So we have 10 sin 45. We have another 10 sin 45. Then we have a minus 14.1. Okay, so this is 14.14. So this becomes 0. Okay, the x component and y component both are 0. Okay, again, if graphical method, that's also simpler. I'll do is I'll take this force. First I'll take this force. I'll keep it here.
And again, next level of shooting will be there. This
Then this is an so it may not match. Okay. So the magnitude better, so that is why it is coming like this. So this should be like this. This distance was 14.14. നേരത്തെ കണ്ടതാണ് 14.14. So this is 14.14 ആണ് ഞാൻ മാർക്ക് ചെയ്തത്. Okay. 14.14. Okay. So basically what is happening is this polygon is closing. Okay, when you are doing in graphical method, whenever this is closing, which is resultant illand, ella forces അങ്ങോട്ടും ഇങ്ങോട്ടും വന്ന് if you just add this up and they are coming to the same point, okay, then it is called then we can say that this will be equilibrium in both directions. So this is a case in which there is equilibrium in both directions.
So coming down
in both directions. Okay, so if you have a system of forces, നിങ്ങൾക്ക് അതിന്റെ equilibrium കണ്ടുപിടിക്കാൻ പറ്റുന്നതാണ് നിങ്ങളുടെ first module is more or less about this. Okay, you have to find about whether the forces are in equilibrium or not. Okay, so when the resultant has zero x component and zero y component, then we can say that the result all the system of forces are in equilibrium. Okay, അപ്പോൾ ഈ ബോഡിയിൽ ഉള്ള ഫോഴ്സുകൾ ഇക്വിലിബ്രിയത്തിലാണ്. അപ്പോൾ ഇക്വിലിബ്രിയത്തിലാണെന്ന് വെച്ചാൽ ഈ ബോഡി അങ്ങോട്ടും ഇങ്ങോട്ടും നീങ്ങില്ല എന്നാണ് അതിന്റെ അർത്ഥം. Okay, so if I increase this force, if I say let's increase this force by let's say 10 to 12, then what will happen? There is a vertical inequilibrium. Vertical direction equilibrium ഉണ്ടാവില്ല, horizontal vertical direction equilibrium ഉണ്ടാവില്ല, horizontal direction equilibrium ഉണ്ടാവും. So it will be okay. Now in this case, ഈ ഒരു സിനാരിയോയിൽ this block will stay as it is. അതുകൊണ്ടാണ് അതിന്റെ equilibrium എന്ന് പറയുന്നത്, അങ്ങോട്ടും ഇങ്ങോട്ടും നീങ്ങില്ല. Okay, so what we can do is we can take up another problem. So this problem is slightly a different problem. Again, I can solve this graphically also, but the idea is that you should be able to get an idea. Equilibrium എന്താണെന്നുള്ള idea. Okay, so let's say so let's draw a circle now. Let's draw a circle.
Formation will be there. So that is why this particular red line. Here, approximately around 2 minutes, the rate of increment is there. Then it is maintaining the constant.
So now let's say
2 to 3 hours. Then again rises. Then it is after 7 days, and it is maintaining, keep on maintaining.
So let's say this is a thread. Okay, this is a thread.
And the next byproduct.
ഈ ത്രെഡ് ഇവിടെയാണ് കിട്ടിയത്.
Starting time is action.
Okay, it is attached to this point. Okay, then let's say we have a what to say.
Action also forming from the beginning state. That also maintaining level 2 to 3 hours. Okay. So this
So we have a wall here.
the reason for all the reaction. Yeah. Then after that, up to 6 hours, it is maintained. Exactly maintained. Then it's keep on.
Okay, now it is touching here. Assume that this is touching here. And this is perfect title of check. So let's say this is touching here. You can make it touch also.
After the initial setting.
Okay, it's touching here. Now, first question. We are observed that
So after normal period, the actual reaction is beginning.
the ball
You can see this. After
is in equilibrium.
normal period, initial set begins.
അതായത് ഈ ബോൾ അങ്ങോട്ടും ഇങ്ങോട്ടും നീങ്ങും. ഇതൊരു സോളിഡ് ബോളാണ്, ഇത് അങ്ങോട്ടും ഇങ്ങോട്ടും നീങ്ങും. This ball has a weight W.
Yes.
That also I will mark. The weight I'll always mark at the center. Okay, central line circle. The weight I mark here. So let's say this is the value W. Okay, this is a thread. This thread has a force T.
CSH plus T.
Okay, okay. So before that, now this is the system which is in equilibrium. Now we have to find the forces which is acting on the system. Is here all the forces like that? Okay, so it is observed that the body is in equilibrium. The body equilibrium observe it. Equilibrium observe it is not moving. It is not moving in the vertical direction. It is not moving in the horizontal direction. That is an observation. Okay. Now, how do you prove that? How do you prove that using physics or using the laws? Newton's law. How do you prove that? So idea of proving that is basically you have to find all the forces acting on this ball. Then you have to tell that all the forces are adding up to zero. Okay, അങ്ങനെ ആവുമ്പോൾ നമുക്ക് അതിനെ പ്രൂവ് ചെയ്യാൻ പറ്റും. This is what I am seeing is just an observation, but I have to prove it that അത് correct ആയിട്ടും using laws of physics and maths. I have to prove that it is in equilibrium. അത് ചെയ്യണമെങ്കിൽ we have to find all the forces. So I have written one force for you, W. Can you tell me what are the other forces? ഈ ബോഡിയിൽ ആക്ട് ചെയ്യുന്ന വേറെ ഫോഴ്സുകൾ എന്തൊക്കെയാണ്? Tell me what are the other forces. നിങ്ങൾ ഒബ്സർവ് ചെയ്താൽ നിങ്ങൾ ഇങ്ങനെ ബോഡി ഇങ്ങനെ തൂക്കിയിട്ടേക്കാന്ന് വെച്ചാൽ ഇങ്ങനെ തൂക്കിയിട്ടേക്ക് അതിങ്ങനെ കിടക്കാം. സോ ഇതിൽ വേറെ എന്തൊക്കെ ഫോഴ്സ് വരാം ആക്ട് ചെയ്യാം? എന്തൊക്കെ ഫോഴ്സ് ആക്ട് ചെയ്യാം? ഇവിടെ
സ്ട്രിങ്ങിന്റെ ടെൻഷൻ കാണോ സാർ?
So Aravind is telling tension of string. Okay. Anybody else? Anyone else?
Force.
Who is that? Okay. Do one thing. Ningal kai book because ningal kai raise your hand. Okay. Just raise your hand. I will hold it. Please raise your hand.
Sir, gravitational force.
Anna Joseph. Okay. Gravitational force. So gravitational force I have already marked. So what I need is what you said is correct. But what the forces that I have marked? Any other forces?
Sir, സെന്ററിന് ലെഫ്റ്റിലോട്ട് ഒരു ഫോഴ്സ് ഇല്ലേ?
Who is that? Okay. Aksar is telling me what there is a force from the center. Center means here. What is answer?
അവിടെ നിന്ന് ലെഫ്റ്റിലോട്ട് ഒരു ഫോഴ്സ്.
Leftilote. Okay. What is this force? So Aksar is telling me there is a force like this. What is it? Any force? And the force. Aksar.
Yes.
What is the force? So basically, I feel Aksar is telling from intuition there is a force like this. അല്ലേ? അതാണ് Aksar പറയുന്നത്.
അല്ലേ, സാധാരണ അങ്ങനെയല്ലേ?
Okay. Okay, fine. Any other ideas? Okay. Any other ideas? Fahad. Fahad.
So,
sir.
Yeah, Fahad, tell me. Fahad.
sir.
പറയൂ.
ഗ്രാവിറ്റേഷണൽ ഫോഴ്സ്.
Gravitational force പിന്നെ
after the dormant period, CSH
പറഞ്ഞോളൂ.
So along with that, the calcium hydroxide will also choose high.
Fahad, അതില്ലേ?
Around 1 to 2 days, the
സാർ
പറഞ്ഞോളൂ.
ഗ്രാവിറ്റേഷൻ ഉണ്ട്. പിന്നെ
as the CSH
പിന്നെ
gel and calcium hydroxide quantity increases, the velocity is in 28 days,
Arjuna Jimon. Arjuna Jimon.
Yes, sir.
Yeah, tell me. What are the forces? Other forces?
Calcium level in the hydrate is here. Monosulfate increases here. Where take this very low level. So
Arjuna Juman, ille, avadi ille.
moving that
Sir, ഉണ്ട്.
Paranjo.
in your system, it will wait for some sulfates.
Arilla.
Sulfate from the external level.
No, sir.
Arilla. Okay. Gada is there? Gada.
Sir.
Yeah. Tell me, Gada.
No, Ari.
Arithilla. Okay. Fine. So basically, always you have to remember when two surfaces are in contact, there is a contact force. There is a contact force. Upon ningal kai ningal oru bithi konde vechu. So there is a contact force between you and the one. Okay. So ഇവിടെയാണ് നമ്മുടെ Newton's law of equilibrium നമ്മൾ യൂസ് ചെയ്യുന്നത്. So basically what is happening? There is a contact force. So there is a force which the wall acts on the ball. Okay, wall force in the mele, wall ball in the mele, contact force. Ingane acting, ingane force. So for every action there is an equal and opposite direction action. Okay, so this ball will put an equal and opposite force to the wall. Okay, this is സംഭവിക്കും, right? So this is, I think this rightly pointed out. ഇങ്ങനെ ഒരു ഫോഴ്സ് വരുന്നുള്ളത്, but then it is basically ആദ്യം പറഞ്ഞ ആൻസർ എന്ന് പറഞ്ഞാൽ ബോൾ വാളിന്റെ മേലെയാണ് ഇങ്ങനെ ഒരു ഫോഴ്സ് ആയിട്ട്, വാളിന്റെ മേലെ ഫോഴ്സ് ഈക്വൽ ആൻഡ് ഓപ്പോസിറ്റ് ഡയറക്ഷനിൽ ഇങ്ങനെ. ദിസ് ഈസ് വാട്ട് ഈസ് നോൺ ആസ് കോണ്ടാക്ട് ഫോഴ്സ്. Contact force. Okay, so this is always perpendicular to the point. അപ്പോൾ നമുക്ക് ഒരു പോയിന്റ് ഓഫ് കോണ്ടാക്ട് ഉണ്ടെങ്കിൽ ഇതാണെങ്കിൽ, so let's say so this is a point of contact. Okay, so this contact force will be always perpendicular to the surface. The surface will be perpendicular ആയിട്ടായിരിക്കും. Okay, ഈ സർക്കിളിന്റെ ടാൻജന്റ് ആയിട്ട് ആക്ട് ചെയ്യും. ടാൻജന്റും ഇത് റേഡിയസ് വരും. Okay, towards the center it will act. Okay, this contact force. So you have to see there is a force which is the wall will put on this, and there is a force which the ball will put on the wall. Okay, but you point to the point there. Ingane force, ingane force. That's why it is in equilibrium. You this point is in equilibrium. Okay. Now, as he said, there is a force string. This string will put a force like this on the wall. String will put a force like this on the ball. Okay. Also, this string will put a force like this on the wall. Equal and opposite. The wall will put a force. Okay, so this is also in equilibrium. Now, what first thing is we have to find what are the different forces which is acting on this. Okay, one is the string is putting a force. It's pretty well clear. You can imagine that string is it is actually the ball string is actually pulling this up. And then the force control. Okay, so this string wall string it is pushing like this. So that is why the string is in equilibrium. Okay. Then there is a contact here. So this wall and the string will have a contact force. That's one force is opposite directional force. Okay. And then when we draw the equilibrium diagram, when we draw the free body diagram, what we have to do is we have to free this body. So I am freeing this body. I body free. I took it out. Okay. Now I have to draw all the forces which is acting on the body. Which is acting on the body. Okay. Now what are the different forces acting on this body? I can say I have to bring this force.
So a lot of people have their own opinion.
This force is there.
So this particular opinion.
Okay. So then I have this strings force, string in the force. So I have to bring that also.
So this dot
strings force, and I have this normal force by the ball.
I break this. Okay. And
okay, so this I can draw here also. Transmissibility, I can draw it here also. Okay. This is force. So I will denote this force as T for tension. I will denote this as N and this is W. Okay. This is I have simplified this. Now, if I want to draw the free body diagram of this portion, here portion of free body diagram that means free body diagram means I am just isolating this force. Evolving and isolating. So this is this portion of the wall. Then there is a normal force like this from wall on the string. Okay. So now what we have to see is നിങ്ങൾക്ക് ഈ ഒരു വാളിനെ ഐസൊലേറ്റ് ചെയ്യുമ്പോൾ you have to find what are all the forces acting on the wall. So there is a force like this. Okay. And there is a force from the okay. So this is for a small portion here. അപ്പോൾ അങ്ങനെ ചെറിയൊരു പോർഷൻ നിങ്ങൾക്ക് ഐസൊലേറ്റ് ചെയ്യാം. But majorly you don't have to worry about this. നമ്മൾ ചെയ്യുമ്പോൾ ഒക്കെ നമ്മുടെ study in the body is this. So our body is isolated. Okay. So these are the forces. Now this I can idealize. So this is what is known as free body diagram. Then I have to idealize this. So I will idealize. How do I idealize? I will assume this ball to be a point. So just take it as a point. Yellow point. Okay. Now all the forces I told you, these are concurrent. I can take the force and I can go it like here. So this is the first force. T. This is the weight. Weight. And this is the normal force. So normal force I can put it like this.
As water solution increases, the distance between each individual layer of actions will be heightened.
No. So this is idealized. But this is what has happened. In the body or the force, this there is a force from the wall. Okay, then there is a force to the string. Okay. So that contact force is there. Then if you want to see free body diagram of this point, let's say hook. There is another thing that you can let's say I'll draw a hook here. So this hook is okay. So if I want to draw the free body diagram of hook in the force, so there is a force like this. There is a force like this. Reaction force.
Then observe the water. Okay. If your system's temperature goes very high.
So these two are forces. Okay. So you don't have to worry about these two. What you have to worry about is this. Either. But in equilibrium, what will happen is all these three forces, these forces will the resultant should be equal to zero. The resultant of these forces should be equal to zero. So that means if this is in equilibrium, if in equilibrium, resultant will be zero. Okay. So or a similar diagram. So I hope how we can use this practically. Okay. So we will do a lot of problems with this, and we will do 3-4 problems. So it is very natural that from free body diagram first time it is very difficult to understand people level. But this is very, very, very important. Basically, the idea is physically what you are seeing physically, you are trying to put it into paper. You are using mathematics and trying to put it into paper. Okay. And trying to study, okay, whether this is moving, this is what is happening. Okay. So the other mechanisms are to work. So let's say by some forces like this. Some forces like this. Okay. Now we have to see whether this is in equilibrium. Okay. And in the chain what we have to do is we can again try the graphical method.
This particular way, this particular
as I told you before. We take this. So we can here. Then you can take this and you can superimpose it here. Okay. So this is completed by the force. Then the resultant is zero. Okay. If this force is of less magnitude, let's say. So let's say this force.
Is hexagonal.
If force
shape is known as calcium hydroxide.
If force thrown out. So say I'm giving you notes, I think. Copy this.
So this is why.
So let's say if this force was less magnitude. Okay, and I have to put it here.
Easy.
Put it here. This is not in
Have you heard
equilibrium.
about ITC?
So this is in equilibrium.
Differential transition zone. It means the distance between the
It is in equilibrium, but this is not in equilibrium.
yeah, the distance between aggregate phase and
Not in equilibrium because we have a resultant force here. Use the white color.
yeah, and
So this is the
very
resultant.
part is completely cylinder phase. Hydrated cylinder
This
phase.
is the
We see a lot of things. This is calcium hydroxide. External parts are calcium hydroxide. We see a lot of
Resultant.
fluids.
Okay, this resultant has an X component, this resultant has a Y component. And this is not in equilibrium. It will move in this direction. It's going to move in this direction. But this will not. Okay, what I hope you are getting some connection. So there is a physical system. The physical system we are converting to free body diagram, and we are seeing this these forces. Now, if these forces if I superimpose, it is in equilibrium. If it is not joining, there is a result. That means to move in that direction. Okay, but everything is what we are doing is just to understand in what direction it is going to move. Much like full exercise chain, right? Any doubts here till now? Any doubts?
Those are having specific shape.
Any doubts here?
Structure.
No doubts? Any doubts? Ask doubts. Okay.
No, sir.
Yeah.
So,
No doubts. എന്താ പറഞ്ഞു മനസ്സിലായെന്നാണോ?
ഫ്രീ ബോഡി ഡയഗ്രത്തിന്റെ ഒന്നുകൂടി ഒന്ന് റിസൾട്ടന്റിന്റെ അവിടെ ഒന്നുകൂടി പറയാം.
എവിടെ വരെയാണ് മനസ്സിലാകാത്ത? ഏതാ മനസ്സിലാകാത്ത?
ബോഡി അതെ അവിടെ
ഈ വരച്ചത് മനസ്സിലായോ? ഫ്രീ ബോഡി.
അത് മനസ്സിലായി.
Okay, so then what will happen is idealization. Idealization, this entire body I have assumed to be a point. So that's the first thing that I know. Okay, then I know that the forces are concurrent. Everything is passing to the center. Okay, normal force perpendicular. This is tangent. This is tangent and perpendicular to the center. Travel circle. So this is passing to the center. Weight is passing to the center. And this tension is also passing through the center because I have designed it like that. Okay. All these forces are passing through this point. So they are concurrent forces. Co-planar concurrent forces. So I have a body acted upon by a set of co-planar concurrent forces, and I have idealized all the forces. Now these forces, this body I have idealized to a point. Okay. That I can start drawing the forces. E force I have drawn like this. E force I have drawn like this. Then this force I have drawn like this. Okay. So E force I can even draw like this also. That's also correct. If I draw like this, then also it will be correct. If I draw like this, then it's also correct. Okay. This is what is known as transmissibility. E line of action I can put it anywhere. If this normal force if I put it here, that is also correct. But then it doesn't make sense with this diagram. But I can do that transmissibility. So this force I have put here, this force I have put here, and weight I have put here. Okay. In idellam kode equilibrium, they will add to zero. The resultant of these three forces will be zero. Okay. If it is not in equilibrium, you will get some. So if you want to see for this diagram, so what I will do is duplicate this. So let's say so I can take this here.
Do you have any doubts?
Then I can take this here. Okay. So but then it is not matching. It is zero because arbitrary scale the body equilibrium the resultant should go and touch here. The resultant force should go and touch here. But corrected scale It will come like this. If it are drawn like this, then it will match. Okay. So this is the process that you have learned in the last class. Basically, resultant force 0 ആണോ അല്ലയോ എന്നുള്ളത് നിങ്ങൾ പഠിച്ചിട്ടുണ്ട്. I am just trying to link it with the physical problem. Right? So I hope this is clear. Now, what I'll do is just give me a minute. So I am giving you the next attendance sheet. Please fill this. This one. Okay. Fill your form.
Can you hear now?
Okay. So let's say that we consider a body of or a what do you say roller of radius 300 mm is acted by a force P. Okay. So what you have to do is find the weight of roller is weight of roller is 1000 Newton. 1000. Okay. So find the minimum force required to move the body. Okay. So in a ball, so ball, let's say if it can be a cylinder also. So again, there is a block here. Okay. So this block is resting here. Okay. So the question is, what is the minimum force? So this height of this block, let's say it's 150 mm.
Okay.
150 mm. This is the height of the block. Okay. So what is the minimum force P that is required to move this body? ഇതിനെ equilibrium അല്ലാണ്ടാക്കാൻ what is the minimum force required എന്നാണ് question. Okay. So first, നിങ്ങൾ അതൊന്ന് ചുമ്മാ try ചെയ്യൂ. You try to draw the free body diagram. Free body diagram. Second, what you do, you find the force, find the P for which the system is in equilibrium. Okay. So this is for tomorrow's class. Then I will be giving some some more work for you in Moodle. Then content session I will update in your group. Okay. So you have to do that also. So first, I hope you are noting this down. A question or paper. First, you have to draw the free body diagram. Imagine what you. So I think your scenario is clear. The weight is actually 1000 Newton. Weight 1000 Newton. There is a force P acting it here. Okay. Then the radius number 300 mm. So this is not to scale. I should have drawn it much smaller. Let me see whether I can correct that.
Again,
okay, fine. No. This is 500 mm. This is 300 mm because the radius is given as 300 mm. So this is 150 mm. What is the force with which we have to just move? Force. This is the force problem. What I want you to draw is you have to draw the free body diagram. Within the free body diagram, then what you have to do is you have to find the value of P. Okay, for which this system is in equilibrium. So think of force. You just try to draw the free body diagram. Try it. It's okay. It's a little difficult, but then this will be what we'll be trying to do in the next class. Okay. Right. So I think I'll give you some more work for today. So do that also before you come for next class. Right. So I hope you have filled it. If there is any doubt I have given in that form, there is an option for you to ask questions. You can ask me question in that. I can clear those doubts also. Okay. So thank you. We'll stop the class for the day. We'll see you tomorrow. Okay. Bye bye.
Okay, we'll finance video.